Hello everyone, I'm Daisuke Kimura from Toho University. In this talk, I'll present our tool, Function Pointer Eliminator for C programs. This work is joint work with Mamudaro Faisal Aramen and Makoto Tatsuta and Koji Nakazawa. First, let me explain our ongoing project. The purpose of the project is to develop automated program analyzer called SLAC for pointer manipulating programs. It is based on separation logic. Separation logic enables to analyze programs in a modular way. The assertion language of our analyzer is symbolic heaps with arrays and lists. The purpose of analyzer is to ensure memory safety. And the input files for SLAC is just C files, so without any additional annotations. So we use some techniques, by abduction and stat checker for symbolic heaps and SMT solver. So this figure shows the whole structure of SLAC. So this is main part of the SLAC, and it uses by abduction solver and stat checker, and we often use SMT solver Z3. The main challenge of the SLAC system is finding loop invariants and function pointer call analysis and recursive calls and etc. And this part is today's main topic, so function pointer eliminator part. So it works as a front end of the SLAC system. So it requires the C files as an input, and it returns the C files without function pointer calls. And one may know the Facebook infer. So Facebook infer also use separation logic as a basic system, but we compare it. So Facebook infer is a bug finder, but our system is aims analyzer and verifies the memory safety. It's the difference between our analyzer and Facebook infer. Now we explain FP, function pointer eliminator for C. FP does a function pointer analysis and elimination of function pointer calls. So this picture shows the whole structure of FP. The input for FP is C files that may contain function pointer calls, and its output is also C files, but without function pointer calls. FP consists of two modules, analyzer module and transformer module. So A module invokes SVF library to get a function pointer information, and then extract from that extract function pointer information from the result from SVF library. And finally, A module makes JSON file, then return it. And then T module, the input for T module is JSON file and the original C files, and it transforms the original C files to C files without function pointer calls. Now I explain the basic behavior of A module with a simple input file. It is an example of input file, and this side is its output. It is written in a JSON format. The input file starts from struct A with a function pointer field f. It has a function type, a void input, and integer output. f1 and f2 are function names with the same function type. In the main function, a function pointer fp is declared here. It has the same function type. fp is initialized by f1 here, and fp is called. Then fp is updated by f2, and fp is called again. aa is a pointer to struct a, and aa arrow f is initialized by f2, and it is called here. In the JSON format output file, it has 3 blocks. Each block corresponds to each function pointer call. The first block corresponds to the first function pointer call. Its name fp, and its possible value is f1 and f2. We note that it is not exact evaluation of the current fp. it is over approximation comes from the SVF analyzed result. The second part corresponds to the second function pointer call FP, and the third block corresponds to the third function pointer called AARF, and it has a pointer name AA and a field name F1. So this one is additional. It is automatically added by LLVM. This slide explains the behavior of T module. T module requires two inputs. First one is JSON file produced by A module, and the second one is original C source code. And in this slide, we use the same example as the previous page. So this JSON file is the same as in the previous page. And this side is the output from a T module. And the T module replaces each function pointer call by direct function call. So in this example, the first function pointer call, the possible value of fp was f1 or f2. So it is replaced in this way. So this means, so if the actual value of fp is f1, then use f1, and otherwise use f2. In the second function pointer call, so it is the same. It has the same possible value, so it is also replaced in the same way. For the third function pointer call, AARF, the possible value for AARF was f2, so it is replaced by in this way. The current FPE supports a function pointer call like of this form. So this C is defined this, and D is defined this, and A is defined like this, where E is the expression and FP is function pointer name and F is field name. From this syntax, so our current FP supports like the form like this and like this and like this. So we think this support is enough large class for our purpose, we think, but it is still has an unsupported form. Unsupported form example is like this and like this. So this means functions that return function pointer. So these forms are not supported yet. This is experimental result for the current implementation of FPE. So we test with some three systems: Zip, Git, and OpenSSL. So this column shows the number of files, and this column shows the total lines of C programs. And this column shows the time for A module. And A module contains two modules, two submodules, SVF part and FP extractor part. The mainly so A times that time for A module taken by SVF, and this is time for T module, and this is total time. So from this result, the Git and OpenSSL is a realistic large system, but our FP works in 30 or 60 minutes. And the second table shows the number of function pointer calls. So this is a number of function pointer calls, and this is the maximum number of function names. So this means that for each function pointer call, it has several possible function names. So this is maximum number of that function names. So this is average number of function names. In this talk, we present our tool FPE, function pointer eliminator for C. It works as a front end of the Slack system, and it replaces function pointer calls in C program by function calls without changing its semantics. And it uses the pointer analysis result from SVF. The current version of FPE is available from GitHub. That's all. Thank you for your attention.